Welcome to Computational Mathematics Lesson 1.1. In this tutorial, I'm going to show you how to use Python to solve a simple distance equals speed times time equation. Now, in order to do this, the first thing we need to know are what are the variables we know? What are the input variables? A basic mathematical model has three things: the input variables, the solution process, so the equations we need to solve, and then what are we outputting. So in our case, we're going to know time and speed, so that's our inputs. We're going to solve it using the equation distance is equal to speed times time, and then our output is going to be the distance. So how do we do this on Python? Well, input is always a good start. So the input command tells the user you need to input an answer to the following question. So I'm going to move away from mathematics for a minute. I'm going to type in how are you. Now, what this does is that we've got a phrase and inverted commas. So this tells us that this is a string. Now, what is a string? A string is a set of characters, characters being the individual elements. So, for example, like the letter H, letter O, and so on. And we're going to run this now. So let's run this. And it's given us a question, how are you? So I'm going to put fine. Okay, and then we're done. Now, there's a bit of a problem to this. Let me show you one of the problems. So how are you? I'm going to put, that means nothing. But the computer does not know that. So if I run that again, then it can't really tell the difference. This is a problem, particularly when we come to numbers. Now, let's change this to speed. This is one of the quantities we need to know. I'm going to put input speed. Cool. Now, logically, we are going to want a number out of this, but the computer doesn't know that, so I can just put in anything, and it will say fine. So we need to create a situation where the computer will only accept numerical quantities, and this is done by the float command. So I'm going to type in float here. So float, put another bracket, and one thing when you do in maths, always make sure your brackets are balanced. So what this will do, so we've got the first bracket which contains speed. This is the question we need to answer. And then the second bracket means that float encompasses all of this. So our input's going to be speed. And what float does, float allows us to give a numerical value. This could be a decimal, this could be an integer. And this will help us quite a lot. So now when I type in speed, and let's say I type in I am fine, well, that's not going to work because it's only accepting numerical values, which is very important because speed cannot be how are you, it has to be a number. Now we know this, I am going to copy that over and create one for time. So I'll do that now, and time. So now the user knows what the value of what to input for speed and what to input for time. So the user is quite clear that whatever they type in is going to give us the speed or the time depending on the question they answer. Cool. And you know what, right? We need to now put in the equation. So as I said, the first step is the input. We've got the input, so let's put in the equation. So distance is equal to speed times time. Good. Now, we have some problems here. If I run this, we get 5, and I type in 10, always good. But we haven't defined S and T. The computer does not know that our speed means S, our time means T. So we need to tell it that. One thing to learn is that the computer has no concept. So if S is equal to this, and T is equal to this. So now the computer knows that speed, it assigns speed to the variable S and time to the variable T. And we're now going to run that. So speed is 5, and let's say time is 10. Excellent. We still have another problem. We don't actually know that it's done the job. We're assuming it has, but as we've got no output for distance, then we don't know. So we now need to change that. So now we're going to move on to the output cycle. We talked about the input, which we've done. We've got the equation. Now we're going to do the output. So I'm going to type in print, and we're going to print d. Okay, so that's going to print out a distance. Speed, let's just say 5, and then time 10. And it's printed out 50, marvelous. However, we can still make this code even better. If we look, we printed out the distance, which is 50.0. But if we were just looking at the input and output, we wouldn't necessarily know that that's equal to the distance. We only know that with the benefit of looking at the code. So we still need a command that tells us this is the distance. So what we can do is, again, use our inverted commas and type in distance. And we close the inverted commas, and then we put a number. Yeah. Now, this says to us that when we print out distance, it's going to give us the value d, which is quite handy because this is our value d here. So let's run that again. Speed is equal to 5, time is equal to 10, and excellent! We have got distance as 50, which 5 times 10 is 50. So therefore, we have created a very, very small and basic mathematical model. Let's talk our improvements that we can make, because one thing about mathematical modeling is it's all well and good doing the maths. What can we do to improve it? So first of all, we might want the functionality of just dealing with integers. We might want time to be just integers. So what we can do is we can replace time with an integer. So integer are basically just whole numbers, so integer makes sense. And then what will happen here, speed 5 and time, let's say I put in 4.5. It's not going to work. So if we only wanted time to take certain integer values, then we can apply that restriction. Another thing we haven't done is we haven't taken into account the units. So I'm assuming time is in seconds, and if time is in seconds, we assume speed is in meters per second, which therefore would give us a value of distance in meters. So we want to increase the functionality of that, and in the next tutorial, I will show you how to increase the functionality of this code to include different types of units.